Have you ever truly felt the ground beneath your feet? I mean, really felt it. Not just the concrete of the sidewalk or the floorboards of your home, but the immense, silent, and impossibly ancient world of rock that cradles us all. What if I told you that the map of the world you hold in your mind, that familiar puzzle of continents and oceans, is a fleeting illusion? What if the very ground you stand on is a traveler, a wanderer on a journey so slow and so vast that a human lifetime is less than a single breath? Settle in. Turn down the lights. We are not going on a trip across the globe, but a voyage deep into time itself, to a world that existed long before our own, a world that haunts the very bones of our planet. If you've ever felt that the world holds buried secrets, subscribe and join us as we unearth them together. Our destination is a memory, an echo in stone. We are going to Vastgard. Imagine a world without an Atlantic Ocean. Imagine there is no Pacific to separate the Americas from Asia. Erase the familiar shapes of India, of Africa, of Europe from your mind. Now, picture all the land on Earth, every island, every continent, every speck of dust, gathered together into one colossal, unbroken landmass. A single continent stretching from the North Pole to the South. A world-spanning kingdom of rock and soil named Vastgard, surrounded on all sides by a single planet-wide ocean, the Okeanos Protos. This is not a fantasy. This was our Earth. This was our home, long before the first whispers of humanity. Long before the dinosaurs, in an age so remote it feels like a dream. But what would it feel like to stand there? To breathe an air thicker or thinner than our own? To walk across a landscape where the horizon in every direction was only more land? This is the journey we take tonight. We are going to walk the shores of that lost world, feel the heat of its deserts on our skin, and listen to the silence of its ancient forests. To understand this place, you must first understand the heart of our planet. The Earth is not a static ball of rock. It is a living thing with a fiery heart and a restless skin. Its surface is a mosaic of colossal plates, floating and grinding over a sea of molten stone. Their movement is patient, yet relentless, measured in inches per year, the speed at which a fingernail grows. But give it time, give it 100 million years, and this glacial dance can rearrange the entire face of the world. This is the engine of creation, the force that builds mountains and carves oceans. And it was this force that, over an unimaginable span of time, gathered the scattered lands of the globe into one. Before Vastgard, there were other giants, the forgotten supercontinent of Konoma, a billion years in our past, and Aethelgard, another brief gathering of the world's lands. They too were born from the slow collision of plates, and they too were torn apart by the planet's inner fire. Their stories are written in rocks so ancient they have been bent and melted and buried a dozen times over. They were the ancestors of Vastgard, the first drafts of a unified world. The assembly was a drama played out in slow motion. Imagine two worlds, two continents, adrift on the molten sea of the mantle. Let's call them Laurentia Major and the southern giant of Gondwana Prime. For 100 million years, they drifted toward each other. Between them lay an ancient ocean, a precursor to our Atlantic, its waters filled with life forms we would barely recognize. As the continents converged, this ocean was squeezed out of existence. Its floor was crushed, folded, and driven deep into the Earth's heart, while its waters were scattered into the growing Okeanos Protos. The collision was not a gentle meeting. It was a cataclysm that stretched over an age. Where the two landmasses met, the crust of the planet crumpled like foil. Rock that had once been seabed was thrust miles into the sky, creating a spine of mountains that would have dwarfed our modern Himalayas. This scar of creation, this colossal mountain range, stitched the two worlds together. You can still find its roots today, hidden in the ancient rocks of the Appalachians in North America and the Atlas Mountains of North Africa. They are the quiet tombstones of a vanished ocean and the birth announcement of Vastgard. One by one, other, smaller continents and island chains were swept up in this grand convergence. Siberia, Baltica, 100 smaller fragments, each one colliding and adding its mass to the growing whole. Each impact sent shudders through the planet, fueling volcanoes that painted the sky with ash and raising new mountain ranges that crisscrossed the interior. When the dust finally settled, the map of the world was stark, simple, and breathtaking. One land, one ocean. Vastgard had arrived. It was a world of unimaginable scale. If you were to stand in its deep interior, you would be thousands of miles from the nearest sea. The smell of salt would be a forgotten memory. The climate would be a creature of pure continentality, a beast of savage extremes. Summers would be furnaces, winters would be glacial. There was no ocean nearby to soften the edges, to moderate the seasons. There was only the land, endless and absolute. And yet, this brutal heartland was not devoid of life. It was a crucible, a testing ground where evolution forged its toughest creations. Reptiles learned to conserve every drop of water. Plants grew deep roots and armored leaves. It was here, in the furnace of the interior, that many of the traits that would lead to the age of dinosaurs were first hammered into shape. But there was another side to Vastgard. Along its immense coastline, the story was different. Here, the Okeanos protos breathed life onto the land. Winds carried moisture inland, feeding vast humid forests where rain fell in abundance. Great rivers, born in the central mountains, wound their way across thousands of miles to these coasts, creating sprawling wetlands and fertile deltas. These coastal belts were teeming with life. In the shadow of towering alien trees, strange amphibians and early reptiles hunted. The air here was thick, humid, and rich in oxygen. So rich, in fact, that it allowed life to experiment with size in ways that seem impossible to us now. Insects grew to monstrous proportions. Dragonflies with the wingspans of eagles soared through the misty forests, millipede-like creatures, as long as a modern crocodile crept through the damp undergrowth. It was a world that felt heavy, ancient, and deeply alive. Perhaps the most profound quality of Vastgard, the one that is hardest for us to grasp, was its lack of boundaries. Today, our world is defined by its divisions. Oceans separate continents, isolating ecosystems and allowing unique forms of life to evolve on each landmass. On Vastgard, these divisions did not exist. A river could begin its journey in a region we now call Asia and end it in a sea that would one day border North America. A forest could stretch unbroken across lands that are now scattered across opposite hemispheres. An animal could be born in the heart of what would become Africa, and over its lifetime, wander into the lands that would become South America without ever seeing an ocean. This unity had a powerful effect on evolution. Species were not isolated. They mixed, competed, and spread across the entire globe. Fossils prove this with haunting clarity. The remains of the exact same species of land-dwelling reptile, like the stout, tusked Lystrosaurus, have been found in modern-day South Africa, India, and Antarctica. These creatures couldn't swim across oceans. They didn't need to. They simply walked. They walked across a single connected world. This borderless world was never truly peaceful. The forces that built it were also the forces of its undoing. Beneath the colossal weight of the supercontinent, the Earth's mantle churned with heat. Like a pot of water simmering on a stove, the heat needed to escape. It pushed upward, weakening the crust, stretching it thin in places. Deep, unseen fractures began to form, the first hints of the cataclysmic breakup that was to come. For 100 million years, Vastgard would hold together, a brief, glorious moment of unity in our planet's long and restless history. But its fate was sealed from the moment of its birth. The Earth is a sculptor that never puts down its chisel. Continents drift, oceans open and close. Mountains rise, and are worn away to dust. But while it lasted, Vastgard left an indelible mark on the evolution of life and the deep structure of the world we inhabit today. To understand our own fragmented world, we must first journey back and stand in awe of the time when it was whole. The story of Vastgard does not begin with its creation, but with the ghosts of the worlds that came before. Imagine the Earth 1 billion years ago. The sun was weaker, the days were shorter, and the continents were scattered, alien shapes in a global sea. This was the age of Konoma, the first great supercontinent we can identify with any certainty. Its assembly and breakup are shrouded in the deepest of time, its history pieced together from magnetic traces in rocks that have been weathered and reborn. When Konoma fractured, it set the stage for a cycle that has defined our planet's history. The supercontinent cycle. The Earth, it seems, breathes. Over hundreds of millions of years, it exhales, scattering its lands across the globe. Then slowly, it inhales, drawing them back together into a single mass. After Konoma came Ethelgard, another temporary gathering around 600 million years ago. It too was short-lived, a brief moment of unity before the planet's internal heat once again tore it asunder. The fragments of Ethelgard became the building blocks of Vastgard. Great landmasses like Gondwana Prime, containing the cores of modern South America, Africa, Antarctica, Australia, and India, drifted near the South Pole. Laurentia Major, the heart of North America, sat near the equator, along with smaller pieces like Baltica and Siberia. For millions of years, they were separate worlds, each with its own evolving ecosystems, each drifting on the slow, inexorable currents of the mantle. But they were on a collision course. To truly picture this, you must adjust your sense of time. Do not think in days or years, but in eons. Watch as the Iapetus Ocean, a body of water that once separated Laurentia from Baltica, shrinks inch by inch. As the continents converge, the ocean floor beneath them buckles and is forced downward, melting back into the mantle. The collision is a geological symphony of destruction and creation. Mountains rise, volcanoes erupt, and the land is shaken by earthquakes that would dwarf any in human history. The Caledonian mountain range, whose remnants are found in Scotland, Norway, and the eastern parts of North America, is one of the scars from this particular impact. It is a gravestone for a lost ocean. The final act of assembly came when this newly fused northern continent, Laurussia, began its slow-motion crash into the southern supercontinent of Gondwana Prime. The Rhyic Ocean between them vanished, crushed out of existence. The impact was so immense, it created the central Vastgardian Mountains, a range that may have been the largest in Earth's history, running like a colossal seam down the center of the new supercontinent. While this grand drama of geology unfolded, life was undergoing its own revolution. In the preceding eras, life had been largely confined to the seas, but by the time Vastgard was assembling, the land was turning green. The first forests were spreading across the continents. These were not the forests we know. There were no flowers, no fruit, no broadleaf trees. These were alien woodlands of giant ferns, towering club mosses, and primitive, spore-bearing trees. In the humid, swampy lowlands of what would become North America and Europe, these carboniferous forests grew so dense and vast that their buried remains would one day form the great coal seams that fueled our own industrial revolution. The air in these forests was different too. It was saturated with oxygen, perhaps reaching levels of 35%, compared to our 21% today. This oxygen-rich atmosphere was like a supercharger for life. It allowed insects to achieve terrifying sizes. Imagine dragonflies with the wingspans of gulls, or centipedes 6 feet long. It was a world of giants, a world still experimenting with the limits of what life could be. To the south on Gondwana Prime, the story was colder. Much of this landmass was covered by vast ice sheets. Glaciers carved deep valleys into the rock, leaving behind scratches and polished surfaces that geologists can still see today in South America Africa, and India. This is some of the most compelling evidence that these continents were once joined, huddled together near the South Pole. The existence of polar ice caps and equatorial swamps on the same planet at the same time shows us a world of stark climatic contrasts, a world in transition. As the continents finally merged into Vastgard, these climate zones were smashed together. The ice sheets of the south began to retreat as Gondwana Prime was pushed northward. The equatorial swamps found themselves at the heart of a new, massive continent, their fate tied to the new global weather patterns that were beginning to form. The stage was now set. The slow, violent collisions had ceased. The last oceans between the continents had vanished. The mountains stood impossibly high, their peaks scraping a sky filled with volcanic haze. The world had gathered itself into one, but this was not an end. It was the beginning of Vastgard's story. Now that the land was whole, it would create a world of extremes more profound and more challenging than anything life had ever faced before. The forging of Vastgard was a planetary transformation. It was more than just the joining of land. It was the creation of a new Earth system, with new rules for weather, climate, and life itself. The colossal mountain ranges born from the continental collisions were not just static features on the landscape. They were active engines of change. Like the Himalayas today, they tore moisture from the air, casting vast rain shadows across the interior. On one side of the mountains, lush forests might thrive, watered by relentless rains. On the other side, just a few hundred miles away, a desert could stretch for 1,000 miles, starved of water. These mountain chains, the seams that held Vastgard together, became the great dividers of its climate. In the heart of the supercontinent, a new kind of environment was born, the continental interior. So far from any ocean, this region was a world unto itself. Moisture-laden winds from the Okeanos Protos would shed their rain long before reaching this deep core. The result was a desert on a scale that dwarfs anything on Earth today. It may have stretched for millions of square miles, a vast expanse of sand, rock, and salt flats under a merciless sun. Geologists find the footprints of this great desert everywhere. They are called red beds, layers of sandstone and shale stained with iron oxide, the unmistakable signature of a hot, arid environment. These red rocks are found in North America, Europe, Africa, and South America, in layers that correspond perfectly to the time when they were all joined together as the arid heart of Vastgard. Life in this interior was a testament to endurance. Plants evolved waxy coatings and deep roots to survive. Reptiles developed scaly, waterproof skin and the ability to excrete salt, allowing them to thrive where amphibians with their moist skins could never venture. It was in this unforgiving crucible that the ancestors of the dinosaurs honed their skills for survival, skills that would later allow them to dominate the planet. But Vastgard was not only a world of desert. Its edges told a different story. The coastline of this single landmass was immense, stretching for tens of thousands of miles. Along these coasts, the climate was moderated by the vast Okeanos Protos. Here, seasonal monsoons became a dominant force. The sheer size of the landmass created an intense heating and cooling effect with the seasons. In the summer, the land would heat up faster than the ocean, creating a low-pressure system that drew in massive amounts of moist air from the sea. This resulted in months of torrential rain, feeding the coastal forests and swamps. In the winter, the pattern would reverse, bringing a long, dry season. This monsoon cycle, far more powerful than any we know today, was the heartbeat of the coastal ecosystems. Life adapted to this rhythm of flood and drought. In the wet regions, towering forests of conifers and seed ferns created a world of green. Their roots held the soil, and their canopies trapped the humidity, creating a stable, sheltered world for countless species. Fossils from these regions paint a picture of incredible biodiversity, a stark contrast to the sparse life of the interior. The very position of Vastgard on the globe contributed to its extremes. The supercontinent straddled the equator, meaning it had vast tropical zones. But its northern and southern tips reached into the polar regions. So, on this single connected piece of land, you could walk from a polar ice cap through temperate forests, across a sun-scorched equatorial desert, and back into temperate and polar zones on the other side. No other configuration of continents in Earth's history has created such a complete spectrum of climates on one continuous landmass. This arrangement also had a profound impact on the oceans. With nearly all the land in one place, the Okeanos Protos became a truly global ocean. Its currents could circle the planet almost unimpeded, creating massive gyres that distributed heat from the equator to the poles. However, tucked into the eastern side of Asgard was a large V-shaped sea, a remnant of older oceans that had not yet fully closed. This was the Tethyan remnant. This sea was shallower and warmer than the open ocean, and it became a crucial cradle for marine life. Its sheltered waters allowed coral reefs to flourish, creating vibrant ecosystems that were a hotspot of evolution for fish, ammonites, and marine reptiles. But perhaps the most significant consequence of Vastgard's formation was its effect on the future of life. By bringing all the continents together, it broke down the barriers of isolation that had separated ecosystems for millions of years. It created a global arena for evolution. Species that had evolved in separate worlds were now thrown together. Predators met new prey. Herbivores discovered new plants. It was a period of intense competition and mixing, a great biotic interchange that would shape the course of life for the next 100 million years. Fossils from South America, Africa, India, and Antarctica show an astonishing similarity during this period, proof that a single cosmopolitan community of animals roamed freely across these now distant lands. Vastgard was whole. Its mountains stood tall, its deserts were forming, and its climate was settling into a pattern of brutal extremes. But it was in this unified world, this single great stage, that the next act of life's drama was about to begin. Wait until you discover the strange creatures that call this world home. If this journey into deep time is sparking your imagination, let us know by liking this video. It helps us know what mysteries you want to explore next. Distance. It is a concept that defines our modern world. We think of far-flung continents, of remote islands, of places separated by vast, unbridgeable oceans. On Vastgard, distance meant something entirely different. There were no oceans to divide. There were no isolated lands. There was only the horizon, and beyond it, more land. To travel across Vastgard was to undertake a journey of almost mythical proportions. You could walk for a year, for a decade, and never leave the continent. You would pass through climates and landscapes that today would require a journey around the world. You would see the sun rise over mountains in what is now Europe and set over plains in what is now North America, all in a single unbroken panorama. The world was one continuous neighborhood. This had a profound effect on the planet's systems. Imagine the wind. On our Earth, its path is broken and chaotic, twisted by the interplay of land and sea. On Vastgard, the wind could have flowed in massive continent-spanning rivers of air. Dust from the central deserts, kicked up by relentless winds, could have traveled for thousands of miles, falling like a fine red snow on the forests of the coast, delivering vital minerals like iron to both the land and the sea. These immense dust storms might have been visible from space. Great plumes of red and tan swirling over the green and blue of the planet. The rivers were equally epic. They were not confined to a single continent's watershed. A river born in the mountains of central Vastgard might have wandered across regions that would one day become Africa and South America before finally emptying into the Okeanos Protos. These river systems were the arteries of the supercontinent, corridors of life that penetrated deep into the arid interior. Along their banks, galleries of forests created green highways, allowing animals and plants to move between otherwise inhospitable regions. These were the routes by which life conquered the continent. For the creatures of Vastgard, this borderless world meant that home was everywhere. Ecosystems were not isolated pockets, but graded into one another over hundreds of miles. You wouldn't suddenly pass from a forest to a desert. Instead, you would walk through a slow, seamless transition. The towering trees of the coast would gradually give way to more open woodlands, which in turn would thin out into scrubland. And finally, the last hardy plants would surrender to the open, arid plains of the interior. This gradual change allowed life to adapt incrementally, to push its boundaries little by little. We see the evidence for this incredible interconnectedness in the fossil record. When paleontologists find the remains of an early reptile like Proterosuchus in the Karoo Basin of South Africa, and then find the very same species in the rocks of China, it is a stunning confirmation of this borderless world. These were not coastal animals. They lived inland along rivers. For them to have populated both regions, they must have simply walked, following the river systems that connected the entire landmass. This free exchange of life also meant that competition was global. An evolutionary innovation that arose in one part of Vastgard could quickly spread across the world. A more efficient predator, a faster herbivore, a more drought-resistant plant. These adaptations did not remain local. They were tested on a planetary scale. This turned Vastgard into a high-pressure evolutionary furnace, accelerating the development of new traits and lineages. It was a world where only the most adaptable could thrive. Imagine yourself standing in one of the transitional zones, a vast savanna-like plain between the wet coasts and the dry interior. The sky above you feels impossibly large. The horizon, a perfect unbroken circle. In the distance, you might see a herd of dicynodonts, stout, tusked herbivores, moving slowly across the plains, their heavy bodies a testament to a world without sleek, fast predators. Perhaps a gorgonopsian, a saber-toothed predator that was part of the group that led to mammals, watches them from a rocky outcrop, its powerful body coiled in anticipation. The air is dry, the sun is hot, and the landscape is painted in muted tones of ochre, brown, and pale green. There is no sense of an edge to the world, no comforting proximity of a coast. There is only a profound, humbling sense of scale. Even the heavens would have looked different. With all the landmass concentrated in one hemisphere, the view of the night sky would have been spectacular and strange. The great sprawl of the Milky Way would have wheeled overhead, but the constellations, the familiar patterns we see, would have been entirely different. Standing in the heart of Vastgard, you would be under a sky that no human has ever seen, a sky that reflected the alien geography of the world below. This was the true nature of Vastgard. It was not just a large piece of land. It was a single interconnected system where rock, water, air, and life were woven together on a planetary scale. Its unity was its defining feature, the source of both its incredible stability and its brutal extremes. It shaped the winds, the rains, and the very path of evolution, and it set the stage for the dramatic transformations that would challenge every living thing that called this borderless land home. This massive, unified world was about to test the limits of life in ways it never had before, and the results would be both terrifying and beautiful. Though Vastgard was a single landmass, it was a world of two faces, the lush living coasts and the stark, silent interior. The contrast between them was one of the most defining features of the age. Along the thousands of miles of coastline, the great Okeanos Protos was a constant, life-giving presence. Its waters were warm, and the air above them was laden with moisture. This moisture was carried inland by steady winds, creating a humid, subtropical climate that supported some of the most vibrant ecosystems on the planet. These coastal regions were a world of green. Vast swamps and wetlands fringed the land, their waters teeming with ancient amphibians, strange armored fish, and a host of invertebrates. These were the landscapes of the late Carboniferous and Permian periods, places where the water and land were in constant negotiation. Towering forests of primitive trees, like the giant club moss lepidodendron and the seed fern Glossopteris, covered the lowlands. Their leaves formed a dense canopy that trapped humidity, creating a steamy greenhouse-like environment on the forest floor. Fossils from these areas, such as the famous Joggins fossil cliffs in Nova Scotia, preserve entire forests, showing us snapshots of these ancient worlds. We see the hollow stumps of trees, the tracks of giant arthropods, and the fossilized bones of the first reptiles that made their homes in these verdant realms. Life here was abundant, but it was also locked in a fierce competition for resources. The air, thick with the scent of damp earth and decaying vegetation, would have buzzed with the sound of giant insects. Early reptiles and synapsids, the group of animals that would eventually lead to mammals, hunted in the dappled sunlight, their senses tuned to the slightest movement in the undergrowth. The rivers that flowed through these coastal plains were broad and slow-moving, depositing rich layers of silt that created fertile floodplains. These were the most habitable zones on the entire supercontinent, and they supported a density and diversity of life that stood in stark opposition to the world that lay deeper inland. To journey away from the coast was to journey into another world. With every mile, the influence of the ocean would diminish. The air would grow drier, the rains less frequent. The dense forests would thin out, the trees becoming smaller and more scattered, eventually giving way to open plains and scrublands. This was the transitional zone, a vast expanse of semi-arid savanna that formed a buffer between the wet coasts and the Great Desert. Life here was tougher, more nomadic. Herds of herbivores would have migrated across these plains, following the seasonal rains in search of fresh vegetation. And then you would reach the great interior. Here, you were as far from an ocean as it was possible to be on planet Earth. This was a desert heartland of unimaginable scale. The sun beat down from a sky that was almost always cloudless. The temperature swings would have been brutal, with scorching hot days giving way to frigid nights. Rain was an exceptionally rare event, a brief, violent downpour that might not be seen again for years. The landscape would have been a mesmerizing desolation of red rock, shifting sand dunes, and vast, cracked salt flats where ancient lakes had evaporated long ago. The wind would have been the only constant sound, a dry whisper or a howling gale that sculpted the land over millions of years. But even here, in this seemingly lifeless world, there was life. This was a land for specialists, for survivors. Drought-resistant plants, perhaps resembling modern welwitschia or yucca, would have clung to life in sheltered canyons, or along the paths of ephemeral rivers that flowed only after a storm. The animals were masters of conservation. Small reptiles and synapsids would have spent the hottest parts of the day in burrows, emerging at dawn and dusk to hunt. Their bodies were efficient machines, built to waste not a single drop of water. The fossils we find from this region are of hardy, tough creatures. Their bones often found in disorganized jumbles, evidence of a flash flood that swept through a dry riverbed, a sudden, violent punctuation in a long history of drought. This stark division of Vastgard into a wet, vibrant coast and a dry, barren interior was a powerful engine of evolution. It created two separate arenas where life had to solve different problems. On the coast, the challenge was competition. In the interior, the challenge was survival against the elements. The animals and plants that evolved in these two different worlds would eventually be remixed and reshuffled as the continent began to break apart, creating the rich tapestry of life that would define the age of dinosaurs. To walk from the coast to the interior of Vastgard would be to witness the power of water. You would see its abundance create a paradise, and its absence create a beautiful, terrible emptiness. You would understand, in a way that is impossible on our fragmented modern Earth, how a single landmass could contain both the cradle of life and its most extreme testing ground. It was a world of contrasts, held together by a single geography, a single sky, and the unending passage of deep time. The planet was preparing for a great trial, and the harshness of its interior was forging the very creatures who would be best equipped to survive it. As you journey deeper into the heart of Vastgard, the green of the coast becomes a distant memory. The air loses its humidity, becoming thin and sharp. The ground beneath your feet transitions from soft soil to sun-baked earth, and finally to the red, iron-stained sand of the great interior. This is the core of the supercontinent, a realm defined by its profound distance from the life-giving sea. Here, the sky is a vast, indifferent canvas of blue, rarely softened by clouds. The sun is not just a source of light and warmth. It is a relentless, oppressive force. During the day, it heats the rock and sand until the air shimmers, creating mirages that dance on the horizon. At night, with no clouds or moisture to trap the heat, it radiates away into space, and the temperature plummets, bringing a biting cold to the desert. This daily cycle of extreme heat and cold would have been one of the greatest challenges for life. Any creature or plant that lived here had to be able to withstand these violent swings. The landscape itself was a testament to the power of wind and aridity. Vast dune seas, their sands the color of rust, would have stretched for hundreds of miles, their shapes constantly shifting with the prevailing winds. In other areas, the ground would be a stony pavement of pebbles, all the finer sand having been blown away over millennia, leaving behind a lag deposit known as a desert pavement. Rocky plateaus and mesas, their sides carved by wind-blown sand, would have risen from the plains, their flat tops offering a vantage point over the endless empty expanse. The geology tells this story clearly. The thick layers of cross-bedded sandstone we find in places like the Colorado Plateau are the fossilized remains of these ancient dune fields. Salt deposits, sometimes thousands of feet thick, mark the locations of vast inland seas that had no outlet to the ocean and simply evaporated under the intense sun, leaving behind their mineral burden. These are the ghosts of lost lakes, silent witnesses to an age of unimaginable dryness. Life in this great interior was sparse, but it was not absent. It was a world of opportunists and specialists. Along the dry riverbeds, known as wadis, hardy, deep-rooted plants would have survived, their entire existence a patient wait for the next flood. When the rare rains did come, they would have been catastrophic. A storm in mountains hundreds of miles away could send a wall of water surging down a dry channel, a torrent that would rage for a few hours or days before being swallowed by the thirsty sand. In the wake of such a flood, the desert would bloom. Dormant seeds would spring to life, covering the landscape in a brief, vibrant carpet of green. This sudden abundance would have drawn animals from all around. Herbivores would feast on the ephemeral plants, and predators would follow them. For a few short weeks, the desert would be a place of plenty. Then, just as quickly, the sun would reassert its dominance, the plants would wither, and the animals would retreat to the few permanent waterholes or disperse back into the vast emptiness. The animals that made this place their permanent home were marvels of adaptation. Early reptiles like pariasaurs, large armored herbivores, had barrel-shaped bodies that may have housed complex digestive systems to extract every last nutrient from tough, dry plants. Many of the synapsids here were burrowers. Creatures like Deictodon, a small tusked herbivore, dug extensive corkscrew-shaped burrows to escape the daytime heat and to find moisture deep in the soil. These burrows are found in abundance in the fossil record, painting a picture of a world where much of life happened underground. The predators, like the fearsome Gorgonopsians, were likely adapted for endurance, capable of traveling vast distances between kills. Their survival depended on an intimate knowledge of a landscape where food and water were scattered and unpredictable. The silence of this world would have been profound. There were no birds to sing, no buzzing chorus of insects as we know them. The dominant sound would be the wind, a constant presence, sometimes a gentle whisper, sometimes a sand-blasting shriek. The occasional cry of a reptile or the scrape of claws on rock would be startling intrusions into the immense quiet. This great interior was not just a desert, it was the engine of Vastgard's climate. The immense high-pressure system that sat over this hot, dry core in the summer months was what drove the powerful monsoons on the coasts. The dust lifted from its surface fertilized the distant ocean. In this way, the barren heart of the continent was inextricably linked to the vibrant life at its edges. It was a world of stark and beautiful desolation, a place that pushed life to its absolute limits. To travel through the heart of Vastgard would be to experience a sense of isolation and scale that is almost impossible to comprehend today. It was the quiet, empty center around which the rest of the living world turned, and it was in this very emptiness that the resilience of life was most profoundly demonstrated, setting the stage for the survivors who would inherit the earth after the coming catastrophe. While the heart of Vastgard baked under an unforgiving sun, its long and winding edges were in a constant, intimate dialogue with the sea. This was the domain of the Okeanos Protos, the single planet-spanning ocean that surrounded the supercontinent. Its influence was the counterpoint to the harsh aridity of the interior, a source of moisture, moderation, and life that shaped the coasts into a world of their own. Panthalassa, as this ocean is sometimes called in our old books, was so immense that its horizons would have seemed infinite. From any shore on Vastgard, you would look out upon a seemingly endless expanse of water, with no distant land to break the view. This ocean was not a passive body of water. It was the planet's primary climate engine. Its currents, flowing in vast, slow gyres around the single continent, circulated heat from the equatorial regions toward the poles, creating a more graded and stable temperature regime along the coasts than anything found inland. These currents were simpler and perhaps more powerful than the complex circulatory system of our modern, fragmented oceans. Where the land met the sea, a dynamic and fertile world was born. The coastlines of Vastgard were not uniform. In some regions, the mountains born of continental collision ran right down to the sea, creating dramatic cliffs and rocky shores. In other areas, broad, flat coastal plains sloped gently into the water, creating vast tidal flats and shallow marine environments that stretched for hundreds of miles. These shallow seas were the nurseries of the ocean. Warmed by the sun and enriched by nutrients washing off the land, they were incredibly productive ecosystems. Ancient reefs, built not by the corals we know today, but by different organisms like sponges and bryozoans, created complex underwater cities. The waters would have been thick with life. Schools of primitive, heavily armored fish, coiled ammonites, their chambered shells a masterpiece of natural engineering, and strange arthropods like the trilobites, ancient rulers of the seafloor who were in the final chapter of their long reign. The rivers of Vastgard poured into these coastal seas, carrying a constant supply of sediment and dissolved minerals from the continent's interior. This runoff was the foundation of the marine food web. It fueled blooms of plankton, which in turn supported everything from the smallest filter feeders to the largest marine predators. Early sharks, sleek and efficient hunters, patrolled these waters alongside larger, more primitive fish that would have been unlike anything alive today. The mood of the ocean also shaped the land. The powerful monsoon cycles brought dramatic seasonal changes to the coasts. During the wet season, torrential rains would cause massive flooding, and the sea itself might be whipped into a fury by powerful storms. During the dry season, the landscape would change. The rivers would shrink, and parts of the shallow sea might even become hypersaline lagoons as evaporation outpaced the inflow of fresh water. Life in this zone had to be adapted to these constant shifts. Along the eastern edge of Vastgard, the great V-shaped Tethyan remnant provided a different kind of marine environment. It was more sheltered than the open expanse of the Okeanos Protos, a vast inland sea that became a unique cradle of evolution. Its warmer, calmer waters were a hotspot for the development of new species, many of which would later spread out into the wider world ocean. The air along the coasts would have been thick with the smell of salt and the cries of early reptiles that might have hunted along the shoreline. The sound of the waves would have been a constant rhythm, the heartbeat of the ocean against the land. It would have been a world of constant motion, of tides rising and falling over vast mudflats, of storms rolling in from the sea, and of life endlessly adapting to the boundary between two worlds. To stand on a vast Guardian coast would be to feel the immense power of the planet's two dominant features, the single land and the single ocean. You would see the green of the land reaching out to meet the blue of the sea. You would feel the humid, salt-laden wind on your skin. You would sense that this boundary was not a line, but a zone of creation, a place where the fertility of the land and the immensity of the ocean met and mingled. These coasts were the vibrant, living skin of the supercontinent, a stark contrast to the stark, silent heart. And it was this interplay between the edge and the center that made Vastgard such a dynamic and complex world. The ocean was not just a border, it was the source of the rain, the driver of the winds, and the ultimate cradle from which much of life on land had once emerged. It was the other half of the world, forever bound to the great land it encircled. To breathe the air of Vastgard would have been an alien experience. The atmosphere of our planet has not been a constant. It has evolved, shifted, and transformed in concert with geology and life itself. The air of that ancient world was a different substance, carrying a different mix of gases, and this chemistry had a profound impact on the creatures that lived and breathed within it. During the late Carboniferous period, as Vastgard was completing its assembly, oxygen levels in the atmosphere were extraordinarily high, possibly peaking at around 35%. This oxygen-rich air was a direct result of the vast coal swamps that covered the equatorial regions. These forests were so prolific and buried so quickly that huge amounts of carbon were locked away underground before they could decay and release carbon dioxide. The net result was an atmosphere supercharged with oxygen. This had dramatic consequences. For one, it made the air denser, which might have made flight easier for the first winged insects. More importantly, it allowed for gigantism, especially among arthropods. Creatures like insects and millipedes rely on simple tubes called tracheae to deliver oxygen directly to their tissues. The size they can reach is limited by how efficiently oxygen can diffuse through these tubes. In a hyperoxygenated world, that limit was pushed far higher. This is why we find fossils of Meganeura, a dragonfly-like insect with a wingspan of 2.5 feet, and Arthropleura, a millipede relative that grew to be over 8 feet long. They were living proof of the air they breathed. This oxygen-rich air would have also made fire a far greater hazard. Wildfires, sparked by lightning or volcanic activity, would have been incredibly intense and fast-moving. They would have swept through the forests of Vastgard with terrifying fury, playing a major role in shaping the ecology of the time. Imagine a forest fire in an atmosphere with nearly twice the oxygen content of our own. It would have been an inferno on a scale we can barely comprehend. However, this high oxygen world did not last. As Vastgard fully formed and the climate shifted into the Permian period, the great coal swamps began to dry up. The interior of the continent became arid, and the vast forests that had acted as the planet's oxygen factories dwindled. As a result, oxygen levels began to fall. By the late Permian, they may have plummeted to as low as 12 to 15%. At such low levels, breathing would be difficult for humans at sea level. The animals of the time had to adapt. This atmospheric shift likely drove the giant insects to extinction and favored the evolution of more efficient respiratory systems in vertebrates. The reptiles and synapsids that came to dominate the Permian world had lungs and circulatory systems capable of extracting enough oxygen from the thinning air. This environmental stress was a powerful driver of evolutionary innovation. Carbon dioxide levels also fluctuated dramatically. Periods of intense volcanic activity, especially along the rift zones where the continent was beginning to feel the strain of future breakups, would have pumped enormous quantities of CO2 into the atmosphere. This would have created intense greenhouse effects, raising global temperatures and further enhancing the aridity of the interior. The very chemistry of the air was a reflection of the planet's turbulent geology. Life, in turn, shaped the air. The spread of forests drew down CO2, while their decay released it. The delicate balance was in constant flux. The sky itself might have appeared different. With different atmospheric densities and compositions, the way light was scattered could have changed. Perhaps sunrises and sunsets were more vivid, or the sky a deeper shade of blue. The air of Vastgard was a dynamic and powerful force. It was both a product of the world's geology and life, and a critical factor in shaping them. To inhale that air would have been to take in the essence of a different world. It was an atmosphere that could fuel giants, and then, in its decline, test the very limits of survival. Every breath was a connection to the deep, hidden processes of the planet. The slow burial of carbon, the fiery outgassing of volcanoes, and the collective respiration of an entire world's worth of life. It was the invisible medium in which the entire drama of Vastgard unfolded. The world of Vastgard was being prepared for a new dynasty. The age of amphibians was waning, and a new kind of creature was poised to conquer the land. This was the era before the dinosaurs, a time when the world was ruled by their cousins and their precursors. A bizarre and fascinating menagerie of animals testing the limits of life on a supercontinent. The key to this new age was an evolutionary miracle, the amniotic egg. Amphibians were tied to the water, needing to lay their jelly-like eggs in ponds and swamps to prevent them from drying out. But a new group of animals, the first true reptiles, evolved an egg with a protective shell and internal membranes. This was, in essence, a private pond, a self-contained life support system that allowed them to lay their eggs on dry land. This single innovation severed the final tie to the aquatic world and opened up the vast, arid interior of Vastgard for conquest. The land was now theirs for the taking. Among the most successful of these early land conquerors were the synapsids. This is the group to which we, as mammals, belong. But back in the Permian period, they were a diverse and dominant group often referred to as mammal-like reptiles. They were not quite reptile and not yet mammal, but something in between. They ranged from small scurrying insect eaters to the apex predators of their time. One of the most iconic was Dimetrodon, a formidable carnivore with a spectacular sail of skin, supported by long spines growing from its vertebrae. This sail was not for defense, but was likely a sophisticated radiator, allowing it to warm up quickly in the morning sun to get a jump on its cold-blooded prey and to cool down in the midday heat. It was a walking, breathing testament to the challenges of temperature regulation in Vastgard's extreme climate. But the synapsids were not all predators. Great herds of herbivores, the dicynodonts, roamed the plains. These were stout, barrel-bodied creatures with turtle-like beaks and, in many species, a pair of tusks. They were the dominant plant eaters of the late Permian, and their fossils are found all over the world, a clear sign of their success in the borderless world of Vastgard. They were adaptable, resilient, and they represented one of evolution's first great experiments in large-scale herbivory on land. The top predators were fearsome. The Gorgonopsians were a group of carnivorous synapsids that evolved into sleek, powerful hunters. With long, saber-like canine teeth and skulls built for a powerful bite, they were the wolves and lions of their age. Imagine a creature the size of a bear, with the sleek build of a cat and a reptilian appearance, stalking the sparse woodlands of the Vastgardian interior. They were the culmination of a long evolutionary arms race, perfectly adapted to hunt the large, tough herbivores of their time. In the oceans, life was equally dynamic. While the trilobites were fading, ammonites were flourishing, their beautifully coiled shells filling the seas. Sharks were diversifying, and large predatory fish ruled the deeper waters. The first marine reptiles were also beginning to appear, tentative pioneers returning to the sea from which their ancestors had long ago crawled. On land, the stage was being set for a dramatic transition. The synapsids, for all their success, were about to face a challenge from another group of reptiles, the archosaurs, the ruling reptiles. This group would eventually give rise to crocodiles, pterosaurs, and, most famously, the dinosaurs. In the Permian, they were still minor players, small, agile creatures living in the shadow of the great synapsids. But they possessed key adaptations, particularly in their posture and breathing, that would give them a crucial advantage in the world to come. The world was filling up. The silence of the early land was being replaced by the sounds of a complex ecosystem, the heavy tread of herbivores, the rustle of a predator in the undergrowth, the splash of an amphibian in a coastal swamp. This was a world on the cusp of the familiar. The players were strange, the landscape alien, but the drama was one we recognize. The eternal dance of predator and prey, the struggle for survival in a changing world. Vastgard was the theater for this drama. Its immense size provided a vast stage, and its extreme climates were the selective pressures that drove the evolution of these incredible creatures. But a shadow was gathering. The very geology that had built this world was about to unleash a catastrophe of unimaginable proportions. The reign of the synapsids, the age before the dinosaurs, was about to come to a fiery, sudden, and devastating end. The forests of Vastgard were realms of deep time, silent and strange. To walk among their trees would be to enter a world without the familiar comforts of our own. There were no flowers to scent the air, no birds to sing from the branches, no buzzing of bees. It was a world of green and brown, a world of spore and seed, a world still learning the language of life on land. These were not singular monolithic forests, but a mosaic of different types, each adapted to the specific climate of its region. In the wet equatorial belt along the Tethyan remnant, the coal swamps of the Carboniferous period gave way to lush Permian forests, dominated by a single remarkable plant, Glossopteris. This was a seed fern, a woody, tree-like plant with distinctive tongue-shaped leaves. For millions of years, it was the most dominant tree in the southern hemisphere, the great kingdom of Gondwana prime. Its fossils are found in South America, Africa, India, Australia, and Antarctica. And this shared flora was one of the key pieces of evidence that Alfred Wegener first used to propose his theory of continental drift. The discovery of the same fossil leaf on continents separated by thousands of miles of ocean was the whisper of a lost, united world. These Glossopteris forests would have been dense and shaded, the ground carpeted with a thick layer of their fallen leaves. They formed the base of a complex food web, feeding a host of insects and the great herbivorous synapsids that browsed beneath their branches. In the northern hemisphere, the forests were different. Here, conifers were beginning their slow rise to dominance. These were not the pines and firs we know, but their ancient ancestors, trees like Walchia, which resembled modern Norfolk Island pines. Their needles and cones were adaptations to a drier, more seasonal climate. They formed vast open woodlands that stretched across the northern parts of Vastgard, their resinous scent filling the air. Alongside them grew the cycads, stout, palm-like plants with tough, leathery leaves, and the strange, towering horsetails, or calamites, which formed dense thickets along rivers and in marshy areas. These forests were a vertical world. The canopy was the domain of insects and the small reptiles that hunted them. The forest floor, a world of shadow and decay, was home to giant arthropods, amphibians, and the larger reptiles and synapsids. The process of decay itself was different. The fungi and bacteria that efficiently break down wood today were still in their evolutionary infancy. This meant that when trees fell, they often did not rot away completely. In the swampy lowlands, they were buried, and over millions of years, compressed into coal. On drier ground they might lie for centuries, their slow decay shaping the soil beneath them. The sound of these forests would have been one of subtle movements, the rustle of leaves in the wind, the scuttling of some unseen creature in the undergrowth, the splash of an amphibian in a nearby stream. The dominant sounds were elemental. There was no bird song to greet the dawn. The silence would have been profound, a deep, ancient quiet that we can no longer experience on Earth. These forests were not just habitats, they were planetary engines. Through photosynthesis, they pumped oxygen into the atmosphere, and by locking away carbon and coal, they profoundly altered the planet's climate. Their roots stabilized the soil, preventing erosion and shaping the flow of rivers. They were an integral part of the Earth system, a living network that bound the supercontinent together. They followed the great river systems deep into the interior, creating green corridors that acted as highways for migrating animals. They climbed the foothills of the great mountain ranges, their composition changing with altitude. They were dynamic, ever-changing ecosystems, responding to the slow shifts in climate over millions of years. But these ancient forests were also vulnerable. Their reign was dependent on a stable climate, and the world of Vastgard was anything but stable. They were about to face a trial by fire, a global catastrophe that would burn them to the ground and replace them with a hardier, scrappier kind of woodland. But for now, in the heart of the Permian, they stood in their silent majesty. To walk through them would be to feel humbled by the sheer age and strangeness of life. It would be a journey into a green, quiet world, a world on the verge of a terrible and transformative upheaval. The great silent forests were holding their breath, waiting for the fire that was to come. Life on Vastgard was an intricate tapestry woven from countless threads of predator and prey, plant and herbivore. In the spaces beneath the canopy of the great forests and across the open plains, a world of smaller creatures conducted the essential business of the ecosystem. This was the age of insects, amphibians, and the first stirrings of the reptilian dynasties. The insects, as we have seen, were giants, beneficiaries of a high oxygen atmosphere. But they were also pioneers. They were among the first animals to conquer the land, the first to take to the air, and the first to develop complex social structures. Primitive cockroaches, some several inches long, scuttled through the leaf litter, playing the same role as decomposers that they do today. In the swamps, the nymphs of the giant dragonflies were fearsome aquatic predators. The very soundscape of Vastgard, the low hum that filled its forests, was the sound of its insect life. They were the base of the food pyramid for many of the first land-dwelling vertebrates. The amphibians, who had been the first vertebrates to walk on land, were still a powerful presence, especially in the wet coastal regions and along the vast river systems. But these were not the small frogs and salamanders we know. The Permian was the age of the temnospondyls, a group of amphibians that grew to enormous sizes. Some, like Prionosuchus, were colossal crocodile-like creatures that could reach up to 30 feet in length, making them the largest amphibians of all time. They were the apex predators of the swamps and rivers, lurking just below the surface, their wide jaws filled with sharp teeth, waiting to ambush fish or any land animal that ventured too close to the water's edge. They were living relics of an older world, a bridge to the time when all life was aquatic, but they were powerful and successful rulers of their watery domain. But the future belonged to the reptiles and their synapsid cousins. Their ability to reproduce on land gave them the ultimate advantage. The smaller reptiles were incredibly diverse. There were lizard-like creatures that hunted insects in the undergrowth, and early heavily built herbivores like Scutosaurus, a pariasaur covered in bony armor plates and spikes, a walking fortress that browsed on the tough vegetation of the plains. The synapsids, the lineage that includes mammals, were the true rulers of the Permian. We have met the great predators like Dimetrodon and the Gorgonopsians and the numerous tusked Dicynodonts, but their diversity was even greater. There were small, agile insectivores that might have resembled a cross between a lizard and a weasel, their sharp teeth perfect for crunching through the exoskeletons of the giant insects. There were also the Cynodonts, a group of advanced synapsids that were becoming remarkably mammal-like. They had differentiated teeth, incisors, canines, and molars for more efficient processing of food. Their posture was more upright, with their legs positioned underneath their bodies rather than sprawling out to the sides. This would have made them more efficient movers, capable of sustained activity. Some paleontologists believe they may have even evolved fur and become warm-blooded, crucial adaptations that would allow their descendants to survive the coming apocalypse and thrive in its aftermath. This intricate web of life was possible because of the sheer scale and variety of Vastgard. The supercontinent provided a multitude of niches, from the wettest swamps to the driest deserts, and evolution filled every one of them. The lack of ocean barriers meant that this was a single interacting ecosystem. The health of the forests on the coast was linked to the herbivores that roamed the interior plains and the predators that hunted them. It was a complex, dynamic, and ultimately fragile system. Fossil trackways give us haunting glimpses into this lost world. In ancient riverbeds, we find the preserved footprints of many different animals, all crossing the same patch of mud millions of years ago. We can see the heavy plodding steps of a large herbivore, the smaller, quicker tracks of a predator following it, and the tiny scurrying prints of insects and small reptiles. It is a frozen moment of interaction, a story written in stone. This was the world of Vastgard in its prime, a world teeming with strange and wonderful creatures, a world where the foundations of our modern ecosystems were being laid. But this complexity, this intricate interconnectedness, was also its great weakness. When the system came under stress, the collapse would be sudden, catastrophic, and almost total. The vibrant, noisy, living world of the Permian was about to fall silent. The creatures that would one day become us were already walking the earth. In the great theater of Vastgard, the synapsids were playing a leading role. They were not just a single type of animal, but a vast and branching lineage, experimenting with different ways of life, from predation to herbivory, from sprawling to scampering. They were the bridge from the cold-blooded past to the warm-blooded future, and their story is our story. Their key innovation was the single opening in the skull behind the eye socket, the synapsid, fenestra. This might seem like a minor anatomical detail, but it allowed for the attachment of larger, more powerful jaw muscles. This gave them a stronger bite, as the ability to chew their food more thoroughly, a crucial first step towards the more efficient metabolism that would eventually lead to warm-bloodedness. The early synapsids, like the famous Dimetrodon, were still quite reptilian in their appearance and posture. They were powerful, but they were just one group among many competing for dominance. As the Permian period progressed, a new, more advanced group of synapsids emerged, the therapsids. These animals took the synapsid body plan and refined it. Their legs were positioned more directly under their bodies, allowing for a more efficient, mammal-like gait. This upright posture meant they could move and breathe at the same time more effectively than sprawling reptiles, giving them greater stamina. Their teeth became more specialized, with clear incisors for nipping, canines for piercing, and molars for grinding. This dental complexity allowed them to exploit a wider range of foods. The therapsids rapidly diversified, becoming the dominant land animals of the late Permian. They included the formidable gorgonopsians, the apex predators we have met, whose saber teeth were the first of their kind on Earth. But the real success story belonged to the herbivores, especially the dicynodonts. These creatures, whose name means two dog teeth, were incredibly successful. They ranged in size from small burrowing animals to creatures as large as a hippopotamus. Their beaks and tusks were perfectly adapted for processing the tough, fibrous plants of the Permian landscape. Their fossils are so numerous and widespread that they are used as index fossils to date rock layers around the world. Their presence on every continent that made up Gondwana Prime is irrefutable proof of the unified world of Vastgard. And then there were the cynodonts, the group that lies closest to mammals. By the late Permian, creatures like Thrinaxodon were small, perhaps nocturnal, and almost certainly had fur and whiskers. Whiskers are a key mammalian trait, a sophisticated sensory system for navigating in the dark. The presence of pits in their fossilized skulls, where nerves and blood vessels would have supplied these whiskers, is strong evidence for their existence. They may have also been warm-blooded, or at least on their way to achieving it. Being small and possibly nocturnal would have allowed them to avoid competing with the larger therapsids and the dominant reptiles of the day. They were carving out a new niche, one that would prove to be a winning strategy for their descendants. To see a cynodont in the Permian twilight would be to see a glimpse of the future. It would scurry through the undergrowth, its whiskers twitching, its large eyes adapted for low light, hunting insects and other small prey. It was not a fearsome or dominant creature. It was a survivor, an opportunist, living in the margins of a world ruled by giants. But it carried within its DNA the blueprint for a new kind of animal, one that would regulate its own body temperature, care for its young, and eventually develop a brain capable of contemplating its own history. The synapsids were a grand evolutionary experiment. They demonstrate that the path to mammals was not a simple, linear progression. It was a sprawling, bushy tree of life, with many different branches being tested, many different solutions to the problem of survival being explored. For a time, they were the undisputed masters of Vastgard. Their herds covered the plains, and their predators stalked the forests. They had conquered the supercontinent, but their reign was built on the stability of their world, and that stability was about to be shattered. The very ground beneath their feet, the restless heart of the planet, was preparing an extinction event so profound that it would nearly wipe the slate of life clean. The synapsids were about to face the ultimate test, and only the smallest, the most adaptable, the most mammal-like among them would make it through to the other side. The world of Vastgard was not just shaped by the slow dance of continents, it was also forged in fire. Beneath its unified crust, the Earth's mantle was a cauldron of heat and pressure. This internal energy had to escape, and it did so through volcanoes. These were the vents, the hot breath of the planet, and their eruptions were a constant and powerful force that sculpted landscapes and altered climates. The volcanoes of Vastgard were concentrated along two main types of features: the subduction zones at the edges of the supercontinent, where the oceanic crust of the Okeanos Protos was being forced beneath the land, and the nascent rift zones in the interior, where the continent was beginning to feel the first strains of being pulled apart. Along the vast coastline of the Okeanos Protos, great chains of volcanoes would have formed, much like the Pacific Ring of Fire today. These eruptions would have been explosive and violent, throwing vast clouds of ash and gas high into the atmosphere. This ash, rich in minerals, would have settled over the land and sea, fertilizing both and creating incredibly rich soils in the coastal regions. But it was the volcanism in the interior that was to have the most profound consequences. As the mantle plume pushed up from below, it stretched and thinned the crust of Vastgard. In these areas, great fissures would open in the ground, not from a single cone-shaped volcano, but from cracks that could be hundreds of miles long. From these fissures, unimaginable quantities of lava would pour out, not in an explosion, but in a vast, silent flood of molten rock. These are known as flood basalts, and they created huge volcanic plains, bearing thousands of square miles of landscape under a thick blanket of black rock. These eruptions were not just a geological spectacle, they were a direct assault on the atmosphere. Each eruption released enormous volumes of gases, primarily carbon dioxide, sulfur dioxide, and methane. The sulfur dioxide would have created sulfate aerosols in the stratosphere, which reflect sunlight and can cause short-term global cooling, a volcanic winter. But the carbon dioxide and methane were powerful greenhouse gases. Over the long term, their accumulation in the atmosphere would have trapped heat and driven global temperatures skyward. For millions of years, this volcanic activity was a background rhythm to life on Vastgard. It was a source of both destruction and renewal. But towards the end of the Permian period, around 252 million years ago, something happened on a completely different scale. In a region corresponding to modern-day Siberia, a massive mantle plume reached the surface, triggering the most voluminous flood basalt eruption in the last half-billion years. This was the event known as the Siberian Traps. For perhaps 1 million years, eruption after eruption poured lava across an area larger than Western Europe. The volume of lava was enough to cover the entire Earth in a layer 20 feet deep. The environmental consequences were apocalyptic. The sheer volume of greenhouse gases released into the atmosphere caused a runaway global warming event. Global temperatures may have soared by as much as 10 degrees Celsius. The oceans warmed and became acidic from absorbed CO2, and they lost their oxygen, becoming vast, stagnant, anoxic pools. On land, the heat and aridity would have been lethal. The acid rain from the sulfur dioxide would have stripped the land of vegetation. This was the trigger for the Permian-Triassic extinction event, the Great Dying. It was the closest life on Earth has ever come to being completely extinguished. Over 90% of marine species and 70% of terrestrial vertebrate species vanished. The great synapsid rulers were all but wiped out. The teeming insect life was decimated. The vast Glossopteris forests were burned to the ground. It was a planetary reset button. The world of Vastgard, once so full of life, fell silent. The fire from within the earth had remade the world. To stand on Vastgard during this time would be to witness a true hell on Earth. The sky would be dark with volcanic haze, the air thick with poisonous gases. Acid rain would fall, and the ground would be covered in ash and fresh lava. It was an event of such magnitude that it is difficult for us to comprehend. But it was this very catastrophe that cleared the stage for the next act in Earth's history. In the ashes of the world that had been, a few hardy survivors would emerge. The age of synapsids was over. The age of the dinosaurs was about to begin, born from the fire and ruin of the Great Dying. For 100 million years, Vastgard had been a symbol of unity, a single world bound together by rock and time. But nothing, not even a supercontinent, is permanent. The very heat that had fueled the apocalyptic eruptions of the Great Dying was also the engine of Vastgard's destruction. The immense blanket of continental crust was acting like a lid on a pot, trapping the heat of the mantle beneath it. This trapped heat weakened the lithosphere, the solid outer part of the Earth from below. The supercontinent began to stretch, to thin and to crack. The breakup was not a single event, but a long, drawn-out divorce that would last for over 150 million years. The first cracks began to appear in the late Triassic period, right down the middle of the continent, between the ancient cores of Laurentia Major and Gondwana Prime. This was the birth of the Central Atlantic Ocean. At first, it was not an ocean, but a series of long linear valleys, known as rift valleys. These valleys would have been geologically active places with frequent earthquakes and chains of volcanoes running down their centers. They would have filled with fresh water, creating vast, long lakes. The fossil record from this time, found in places like the Newark Basin in the eastern United States, shows us what these environments were like. We find the fossils of the first true dinosaurs, small bipedal creatures like Colophysis, living alongside strange crocodile-like reptiles and the few surviving lineages of synapsids. As the rifting continued, the crust stretched so thin that it finally broke. Seawater from the Okeanos Protos and the Tethyan remnant began to flood into the deepening rift valley. A new narrow ocean was born. This young Atlantic was a salty, restricted sea, and in the hot, arid climate of the time, parts of it would have frequently evaporated, leaving behind massive deposits of salt that still lie buried deep beneath the ocean floor today. While the Atlantic was opening, other rifts began to appear across Vastgard. The southern part of the continent, Gondwana Prime, began to fracture. A rift opened between what would become Africa/South America and Antarctica, Australia. Another began to separate India from the other landmasses. Each of these rifts was another step in the dismemberment of the supercontinent. The breakup had a profound impact on the world's climate and on life itself. As new oceans formed and coastlines were created, the extreme continental climate of Vastgard began to break down. More moisture could penetrate inland, and the vast deserts of the Triassic began to shrink. The climate became more humid, more tropical, which favored the spread of lush forests of conifers, cycads, and ferns. This new, wetter world was the perfect environment for the dinosaurs. Having survived the Great Dying and the arid world of the early Triassic, they now found themselves in a veritable paradise. They diversified rapidly, growing to enormous sizes and filling every available ecological niche. The breakup of Vasgard was the catalyst for the dawn of the age of dinosaurs. The process of separation also created new barriers for life. As the continents drifted apart, their populations of animals and plants became isolated from one another. This isolation is a key driver of evolution. The dinosaurs of North America began to evolve differently from those in South America or Africa. This is why, by the late Jurassic and Cretaceous periods, we see distinct dinosaur faunas on each continent. The single cosmopolitan world of Vastgard was gone, replaced by a multitude of separate, evolving worlds. To witness this process would be to see the modern world being born. You would see the continents we know today beginning to take shape, their coastlines slowly emerging from the fracturing supercontinent. The world was becoming more complex, more fragmented, and in that fragmentation, it was becoming more diverse. The breakup of Vastgard was not an ending. It was a transformation. The supercontinent had acted as a crucible, forging the life that would inherit the Earth. Now it was scattering that life across the globe, sending it down new and divergent evolutionary paths. The legacy of Vastgard was not in its unity, but in the rich, diverse world that was born from its dissolution. The single great landmass had played its part. Now it was time for its children, the continents of our modern world, to begin their own long, lonely journeys across the face of the deep. The rivers of Vastgard were the circulatory system of a living continent. They were the arteries that carried water from the mountains and coasts deep into the heartland, and the veins that returned sediments and nutrients to the sea. On a world without oceanic divisions, these river systems grew to a scale that is difficult to imagine today. They were continent-sized plumbing, shaping the land and enabling life in the most challenging of environments. Many of the greatest rivers would have had their sources in the central Vastgardian mountains, the colossal range that marked the suture between the northern and southern continents. Here, snowmelt and orographic rainfall, rain forced by mountains, would have fed torrents that carved their way down from the highlands. As these rivers reached the vast interior plains, they would have slowed and meandered, creating enormous floodplains that could be hundreds of miles wide. These floodplains were the cradles of life in the Triassic period. During the dry season, the rivers might shrink to a mere trickle, but during the wet monsoonal season, they would swell into immense muddy torrents, inundating the surrounding landscape. When the floods receded, they would leave behind a fresh layer of fertile silt. This constant renewal of the soil supported lush vegetation along the riverbanks, creating corridors of green that acted as highways through the otherwise arid landscape. These river corridors were where the action was. The first dinosaurs, small and agile, would have hunted along these riverbanks. Great herds of crocodile-like phytosaurs, the dominant aquatic predators of the Triassic, would have lurked in the murky waters. And the surviving synapsids, like the pig-like placerias, would have congregated near the water to feed on the soft vegetation. The fossil record of the late Triassic, in places like the Petrified Forest National Park in Arizona, is a perfect snapshot of one of these great river ecosystems. We find the fossilized logs of giant conifers that were washed down in floods, the bones of countless different animals, and the preserved burrows of small creatures that lived in the riverbanks. It is a complete world, preserved in stone. The scale of these river systems meant they connected disparate parts of the supercontinent. A log that fell into a river in what is now Central Africa could have floated for thousands of miles and ended up being deposited on a floodplain in what is now Brazil. This is why we find such a consistent fossil record across the different parts of what was once Vastgard. The rivers were a distribution network, mixing and mingling the life of the entire continent. In the driest parts of the interior, the rivers were different. They were ephemeral, flowing only for a short time after a major storm. But even these ghost rivers were lifelines. They would recharge underground aquifers and fill temporary lakes, or playas. These playas would become oases, drawing animals from hundreds of miles around. When they dried out, they would leave behind a cracked mud surface, perfectly preserving the footprints of the creatures that came to drink. These fossilized trackways are some of a most evocative evidence from the time, a direct record of the behavior of these long-extinct animals. We can see the tracks of a predator stalking a herd of herbivores, or the tiny prints of a small mammal ancestor scurrying for cover. As Vassgard began to break apart, these great river systems were torn asunder. The rift valleys that formed became the new low points in the landscape, capturing the flow of water and rerouting the ancient rivers. The birth of the Atlantic Ocean was also the death of the great transcontinental rivers that had once unified Vastgard, but their legacy remains. The vast sedimentary deposits they left behind are the rock formations that hold the fossil treasures of the Triassic. They are the pages of a book written by water, a book that tells the story of life on the supercontinent. To stand on the banks of a Vastgardian river would be to stand at the center of the action. It would be a world of constant change, of flood and drought, of life and death. The rivers were the pulse of the continent, and their steady, patient flow was the force that shaped the land and guided the course of life through one of the most dynamic periods in Earth's history. The sky above Vastgard was a character in its own right. It was the canvas upon which the drama of the climate was painted, a source of life-giving rain and punishing heat. Its voice was the wind, a force that swept unimpeded across the vast open landscapes of the supercontinent. The winds of Vastgard would have been governed by simpler, more powerful patterns than the complex winds of our modern world. The most dominant feature would have been the massive seasonal monsoon. In the summer, the vast interior of the continent would heat up, creating a huge area of low atmospheric pressure. This would draw in moist air from the surrounding Okeanos Protos, leading to months of heavy rainfall along the coasts. In the winter, the pattern would reverse. The land would cool down, creating a high-pressure system that would push dry air outwards from the center of the continent, bringing a long, rainless season to the same coastal regions. This mega-monsoon was the heartbeat of the planet's climate. Its rhythm dictated the lives of every plant and animal. The storms generated by this system would have been epic. Thunderstorms could have grown to colossal sizes, their tops reaching into the stratosphere, their lightning illuminating the landscape for hundreds of miles around. In the dry interior, dust storms, or haboobs, would have been a common occurrence, great rolling walls of red dust that could blot out the sun for days. These storms would have been a major force of erosion, sculpting the rock formations of the desert and transporting vast quantities of sediment across the continent. The sky was also the conduit for the effects of volcanism. When the Siberian traps erupted, the ash and aerosols they injected into the atmosphere would have been spread around the globe by the high-altitude winds, creating a volcanic haze that dimmed the sun and cooled the planet. This would have been a sky of perpetual twilight, a grim, gray canopy under which the great dying unfolded. After the extinction in the Triassic period, the sky would have cleared, but the climate it governed was a harsh one. The world was hot and dry, a greenhouse planet. The sky would have often been a brassy, cloudless dome. The quality of the light would have been different, sharper and harsher, without the softening effect of humidity in the air. Sunrises and sunsets over the red deserts would have been spectacular, the dust in the atmosphere painting the sky in fiery shades of red and orange. The sounds of this sky would have been elemental. There was no bird song, no drone of airplanes. The sounds were the whistle of the wind through rock formations, the distant rumble of thunder, the hiss of sand being blown across a dune. It was a sky that communicated power and immensity. As Vastgard began to break apart, the sky changed with it. The creation of new narrow seas, like the young Atlantic, introduced new sources of moisture into the heart of the dying continent. The climate began to mellow, becoming wetter and more stable. The sky would have become a gentler thing, with more clouds, more frequent and less violent rain. This climatic shift, driven by the changing geography, was what allowed the dinosaurs to flourish in the Jurassic period. The hot, dry red world of the Triassic gave way to the lush green world of the Jurassic, and this was a story written in the sky. To look up at the sky of Vastgard would be to feel the full force of the planet's climate system. You would feel a part of a single, interconnected world, where the heat of the desert heart drove the rains on the distant coast. It was a sky that was both beautiful and terrible, a sky that held the power of creation and destruction. And though the land beneath has fractured and drifted, the fundamental laws that govern that ancient sky are the same ones that govern ours today. The voice of the wind is an echo of a time when it blew across a single unbroken world. For an age, Vastgard was the world. Its life, forged in the crucible of its extreme climate and tested by the fires of the great dying, was hardy, resilient, and ready for a new chapter. But that chapter would not be written on a unified stage. The supercontinent had done its work. It had brought life together, mixed it, and forced it to adapt. Now it was time to send that life on new journeys. The silence that followed the Permian-Triassic extinction was not an emptiness, but a pause. It was the quiet of a world waiting to be reborn. In that quiet, the survivors began to reclaim the desolate landscapes. Life is an irrepressible force. It fills every vacuum. The vast ecological niches left empty by the great dying were an open invitation, and evolution responded with a burst of creativity. The reptiles, particularly the archosaurs, were the big winners. They had survived the apocalypse, and in the hot, dry world of the early Triassic, their water-efficient bodies gave them a decisive edge. From this group, the first dinosaurs emerged. They were not yet the giants of the Jurassic. They were small, bipedal, and lived in the shadow of other, larger reptiles, like the crocodile-like phytosaurs and the heavily built adasaurs. But they were fast, agile, and adaptable. They were the future. The synapsids, the once mighty rulers of the Permian, were reduced to a shadow of their former glory. The only ones who survived were the small burrowing cynodonts. They had ridden out the apocalypse underground. They would remain small nocturnal creatures for the next 150 million years, living in the shadow of the dinosaurs. But they were biding their time. They were honing the traits, warm-bloodedness, fur, advanced parental care, that would make them the inheritors of the Earth after the next great extinction. The world they were all repopulating was still Vastgard, but it was a wounded, scarred version of its former self. The lush forests were gone, replaced by hardy stands of conifers and ferns. The great interior deserts were larger and harsher than ever. It was a tough world for tough animals, and it was on this single connected stage that the first act of the Mesozoic era played out. A dinosaur that was born in what is now Arizona could have walked to what is now Germany. The fossil evidence confirms this. The late Triassic faunas found around the world are remarkably similar. Plateosaurus, one of the first large long-necked dinosaurs, is found in dozens of sites across Europe. Its close relatives are found in South America. They were all citizens of a single world. This interconnectedness was a double-edged sword. It allowed for the rapid spread of successful new species, but it also meant there were few refuges. Life was playing out on a single global stage, but this stage was beginning to crack. The rift valleys that would become the Atlantic were creating new habitats and, more importantly, new barriers. As the continents began to drift apart in the Jurassic, life was ferried along with them. The age of global faunas was over. The age of provincialism had begun. The dinosaurs of Laurasia, the northern continents, began to diverge from the dinosaurs of Gondwana, the southern continents. The Allosaurus of North America was replaced by the Carcharodontosaurus of Africa. The Stegosaurus of the Northern Hemisphere had its counterpart in the Kentrosaurus of the South. This is the ultimate legacy of Vastgard. It was the womb in which the life of the Mesozoic was conceived. Its breakup was the birth, sending that life out into a new fragmented world to follow its own unique evolutionary destiny. Vastgard provided the cast of characters. Its breakup provided the separate stages on which they would play out their epic stories. The silence had been broken. The world was full of the sound of new life, and this life, born on a single continent, was now ready to conquer a multitude of worlds. The story of Vastgard ends not with a bang, but with a slow, inexorable parting of ways. For over 100 million years, it had been the entire world. Now its constituent parts were embarking on their own epic journeys, carrying with them a shared legacy of life and geology. The breakup, which began in the Triassic, accelerated through the Jurassic and Cretaceous periods. The Atlantic Ocean widened from a narrow sea into a true ocean, creating a permanent barrier between the Old World and the New. To the south, Gondwana Prime continued to fragment. Africa and South America pirouetted away from each other. India broke free and began its long, lonely, and rapid journey northwards, destined to one day collide with Asia and create the Himalayas. Antarctica and Australia, still joined, drifted south towards the pole. This continental drift was not just a redrawing of the map, it was a complete overhaul of the planet's systems. As the continents moved, they changed ocean currents, which in turn changed the global climate. The warm, stable greenhouse world of the dinosaurs began to cool as currents like the Antarctic Circumpolar Current were established, isolating the southern pole and allowing a great ice sheet to form. This was the slow, inevitable transition into the icehouse world that we live in today. The life that had been born on Vastgard was now set on divergent paths. The dinosaurs continued to rule on their separate continental rafts, evolving into a spectacular array of forms. The giant sauropods of South America, like Argentinosaurus, became the largest land animals of all time, while in North America, Tyrannosaurus rex evolved into the ultimate apex predator. The mammals, our ancestors, remained in the shadows, small and nocturnal, but they too were diversifying on each continent, quietly laying the groundwork for their future takeover. When the asteroid struck 66 million years ago, ending the reign of the dinosaurs, it struck a world that was geographically recognizable to us. The continents were close to their present-day positions. The world of Vastgard was a distant memory, but it was not forgotten. Its ghost is all around us. The mountains we see, the rocks beneath our cities, the very distribution of life on Earth, all are echoes of that time when the world was one. The echo is there in the shape of the continents. Look at a map. The bulge of Brazil fits almost perfectly into the Gulf of Guinea on the coast of Africa. They were once joined. That is the scar of Vastgard's breakup. The echo is there in the rocks. The coal seams of Pennsylvania were laid down in the same equatorial swamps as the coal seams of Poland. The red sandstones of the American Southwest are the same red sandstones you find in the deserts of Morocco. They were all part of the same great interior desert. The echo is there in the fossils. The discovery of the same land reptile, Lystrosaurus, in Africa, India, and Antarctica, is what convinced many geologists that the continents had indeed drifted. It was the ghost of a walking animal, an animal that could not swim an ocean, that finally proved the existence of the lost world of Vastgard. And the echo is there in our own DNA. The great lineages of life, the mammals, the birds, the reptiles, all had their roots in the Permian and Triassic periods. They are all survivors of the Great Dying, all children of Vastgard. Their shared ancestry is a testament to the time when their distant ancestors all lived together on a single landmass. Pangea, Vastgard, whatever name we give it, was not just a geological curiosity. It was a fundamental chapter in the story of Earth. It demonstrates a profound truth about our planet. It is not static. It is a dynamic, living system, constantly changing, constantly reinventing itself. The continents are not fixed. They are on a journey, and that journey is not over. The Atlantic Ocean is still widening. The Pacific is shrinking. In the distant future, perhaps 250 million years from now, the continents will once again come together to form a new supercontinent. The cycle will continue. To understand Vastgard is to understand the deep, slow pulse of the earth. It is to feel the ground beneath your feet, not as something solid and dependable, but as the skin of a restless, breathing planet. It is to realize that our own time, our own map, our own world is just a single frame in an epic movie that has been playing for billions of years. The story of Vastgard is not over. We are living in its long, lingering echo. Its memory is written in the stone beneath us and the blood within us. It is the silent, powerful reminder that we are all inhabitants of a single, ever-changing world. Don't hesitate to share your own thoughts on this deep history in the comments below. What does it make you feel, knowing the ground beneath you has traveled so far? The story of Vastgard, then, is not truly a story about the past. It is a story about the present and about the very nature of time, change, and our place in the cosmos. We began this journey by trying to feel the ground beneath our feet, and we end it by understanding that this ground is not a foundation, but a vessel. We are all passengers on a continental raft, drifting on a sea of molten rock, part of a journey that began long before us and will continue long after we are gone. The world of Vastgard seems impossibly alien. A single continent, a single ocean, a sky filled with giant insects, and a land ruled by creatures that were not quite reptile and not quite mammal. But the forces that shape that world are the same forces that shape ours. The heat of the Earth's core, the patient dance of tectonics, the delicate interplay of atmosphere, ocean, and life. These are the eternal laws of our planet. Vastgard reminds us that the world we see as permanent is, in the grand scheme of things, profoundly temporary. Our mountains are being worn down, our oceans are changing shape, and life is constantly adapting to a shifting stage. This can be a humbling, even unsettling thought, but it can also be a source of profound wonder. It connects us to a history so deep, it defies imagination. The iron in your blood was forged in the heart of a star, but the calcium in your bones was weathered from rocks that may have been part of the central Vastgardian mountains. The oxygen you breathe is a gift from billions of years of photosynthesis, a process that created the very atmosphere that fueled the giants of the Carboniferous. We are not separate from this history. We are its product. We carry the legacy of Vastgard within us. The breakup of that supercontinent, by creating isolated evolutionary laboratories, is what ultimately led to the incredible biodiversity of our world, including the evolution of our own primate ancestors in the newly formed environments of a drifting Africa. Our story is inextricably linked to the story of that lost world. Perhaps the greatest lesson of Vastgard is one of perspective. In our daily lives, we are consumed by the immediate, by the human scale of time. But the story of the Earth invites us to zoom out, to see our world not as a static picture, but as a dynamic process. It teaches us that change is the only constant, and that even the most catastrophic events, like the Great Dying, are not endings, but violent transitions that pave the way for new beginnings. We live on a remarkable planet, a restless, creative, and sometimes violent world. It has gathered itself into one, and it has torn itself apart. It has fostered life of unimaginable strangeness, and it has come perilously close to extinguishing it entirely. And through it all, it endures. The cycle continues. The continents continue their slow, silent journey, destined one day to meet again. What will that world look like? What new forms of life will walk its shores? We can only speculate, but we can be certain that the echo of our own time and the echo of Vastgard before it will be written into the rocks of that future world. The story never ends. It is simply rewritten again and again by the patient, powerful hand of the earth itself. Thank you for traveling with us on this journey into deep time. If it has made you see our world in a new light, like this video and subscribe for more explorations into the great mysteries of our universe. Look around you. Feel the ground. You are part of a story older than the mountains, and it is still being told.